Hi everyone. This video is on applications using radicals. We're basically going to talk about two different applications. The first one is the distance formula, you can see on the slide here. The second one we'll talk about is the Pythagorean theorem. Maybe I should have done this in reverse order because the distance formula actually comes from the Pythagorean theorem. But in this video, we're just going to talk about the formulas and we're going to do it. Okay, so to find the distance between 2 points, x1, y1, those are subscripts. They're just to differentiate one point from another. So x1, y1, and x2, y2, we're going to use this formula. The distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, I said this really just comes from the Pythagorean theorem. Okay, so here's our first example. We're going to find the distance between these 2 points. So picture them on a graph, on a grid, and we want to know how far is it from one point to the other one. So the first point is -5, 2, and the second point is -1, 6. And I want you also to round it to the nearest tenth. So have your calculator handy. Usually what we do on calculators, when we want to find the square root of a number, you find your square root button and then type the number inside the radicand and then hit equals. Some calculators, it'll automatically put it into decimal notation. Other calculators, like the Casio FX991EX, it'll keep it in simplest radical form. And if you want the decimal approximation, then there's a button above your delete button. It's got an S and a D and an arrow in between the two letters. And you press that and it'll change it to a decimal. So again, it's the SD button and there's an arrow between the S and the D. Press that and bam, gives you the decimal approximation. Okay, so let's do this problem. The first thing is write down the formula. Especially if you have to memorize it, it's always a good idea to write it and write it. By writing it, it gets into your memory. Okay, so there's a formula. And then we're going to use those points, -5, 2 and -1, 6. And I like to put a little x1, y1 next to the first point. And then the x2, y2, either above it or below it on the second point. Okay, so now replace x2 with -1, x1 with -5, y2 with 6, and y1 with 2. You might want to pause it and do that work. Okay, so this is what we got. In parentheses, -1 minus -5, all squared, plus 6 minus 2, all squared. In the first set, we have two negatives. That turns into a positive, so that'll be -1 plus 5, which is 4, so that's 4 squared. And in the second parentheses, that's also 4, because 6 minus 2 is 4. So we have 4 squared plus 4 squared. That'll give you 32. 4 squared is 16, right? Now, we could write this in simplest radical form, but the directions indicate to round to the nearest tenth. So hit your square root button, and then put a 32 inside, and then hit equals. And then you may want to hit the SD button, and it'll give you approximately 5.7. It actually gives you 5.65, but the tens place is a 6, the hundreds place is a 5. So 5 or more, we add 1 to the desired place value. So since it's a 5, add 1 to the 6. Therefore, it becomes 5.7. Okay, I don't think that was too bad. This is the only example of the distance formula. We'll move on. We're going to talk about the square root property. And the reason we're talking about the square root property is because we're going to use it for the Pythagorean theorem. We'll do some more problems in detail on the square root property, but not in this video. Okay, so here's a property. For any real number a, if x squared equals a, then x equals the square root of a, or x equals the negative square root of a. Okay, so we're going to use this to talk about the Pythagorean theorem. And the Pythagorean theorem is an application used to find the length of a side of a triangle. So the negative is not going to do us any value, it's not going to give us any value here. So we're going to omit the negative solution. So that's just for this lesson, okay? It is a solution, the negative value is a solution, but we're not going to worry about it here. Okay, so here's our first example. Find the positive solution. So that's just saying don't worry about the negative. Find the positive solution using the square root property to the nearest tenth. X squared equals 59. So what the square root property says is if we have x squared by itself on the left-hand side, we're going to get rid of the square. But we have to put a square root on the other side. So that's what we're going to do. Get rid of the square on the left-hand side, but put a square root on the right-hand side. That's it. Get rid of the square on the left-hand side, put a square root on the right-hand side. I know it looks more complicated than that, right? We're done basically, except that we want to round it to the nearest tenth. So you're going to, again, get your handy-dandy calculator out and type in the square root of 59. You should get 7.681145718, but we want it to the nearest tenth. So our answer is approximately 7.7. Again, 5 or more, we round up. 4 or less, you leave it alone. So since it was 7.68, we add 1 to the 6. If it was 7.63, then it would remain 7.6. Okay, so that's a square root property. We get rid of the square on the left-hand side, and we put the square root on the right-hand side. So that means that 7.7, if you square that number, it's close to 59. Remember, we rounded, so it's not going to equal 59. But if you wanted to, give it a shot. Put in 7.7 and then square it on your calculator. I'm going to do that right now. You might, if you have a Casio, it might put it into a fraction. Hit that SD button. It gives me 59.29, so it's a little bit more than 59, and that's because we rounded up. So that's right, it's approximately 7.7. Okay, here's the Pythagorean theorem. Given a right triangle means that one of the angles is 90 degrees. So given a right triangle where A and B are the legs of the triangle, So the sides next to the 90-degree angle, those are called the legs of the triangle. And C is the hypotenuse. C is the opposite from the right angle. Here's a picture of a right triangle. Notice that A and B are adjacent to the right angle, which is 90 degrees. And opposite of the right angle is C, called the hypotenuse. I know, Greek, right? Hypotenuse, those are Greek words. Pythagoras was Greek, from Greece. I think around 580 to 500 BC. Actually was a religious person. I believe he had his own cults. A lot of symbolism in his religion. You might want to look it up sometime. Or not. Okay, so we're going to use that theorem to find the missing side of a triangle. So here we have a picture. The directions are to find the missing side of a given right triangle. Again, we're going to round to the tens place. So rounding is one of those things that it depends on the problem. In a chemistry class, you might want 4 significant digits. They'll always tell you what they want you to round to. Okay, so in this place, in this problem, the tens place. Our legs, 5 feet and 14 feet. And we don't know what C is, right? C is called the hypotenuse. All right, let's write down the formula that we're going to use. What is the formula that we're going to use? Right, a squared plus b squared equals c squared. Next, we're going to replace the numbers that we have. We have a and b. So in place of a, put a 5. We won't put in the feet. Just remember to write feet for your answer when you're all done. Replace b with 14, and we don't know what c is, so just leave c alone. You don't have to replace it with the letter x or y. So 5 squared plus 14 squared equals c squared. Okay, now work out each one. Put in 5 squared in your calculator and then 14 squared in your calculator. Add those two numbers up together. $25 plus 196. That gives us 221. And now we're going to use the square root property. It's kind of backwards. It's not an x, it's a c, but that doesn't matter. If you want to, you could put the c on the left-hand side. Just rewrite it, c squared equals 221. If you don't want to, you don't have to. So again, what we're going to do is we're going to get rid of the square on one side, and we're going to put the square root on the other side. Get rid of the square, put a square root. There it is. We got rid of the square, put a square root. So that's what the value of c is. It's the square root of 221. Of course, we're not done. You're going to put that into your handy-dandy calculator. And again, round to the tenths place. You should get 14.9. And don't forget the feet. All right, one more problem. This is a short video. Cool, right? Okay, this time I didn't even put a picture. Find the missing side of a right triangle. We're going to round to the tenths place. A is 7, 7 feet, and C is 13 feet. Which side did they not give us? Right, B. We don't have what B is. So just keep that in mind. We're going to use our same formula. You got it memorized by now, right? A squared plus B squared equals C squared. So we're going to replace the A with 7, the C with 13, and B, we don't know what it is, so just leave it alone. Okay, now 7 squared, 49. How about 13 squared? 169. Okay, but now we don't have the letter squared by itself. We always want to get the letter by itself, right? Whenever we're solving an equation, that's one of our goals. Unless we're factoring, but this one is squared, but there's not another B term, so that's why there's no factoring here. So we can subtract 49 on both sides to get the letter by itself. So minus 49 on both sides. And that gives us B squared equals 120. Now we could use the SRP, the square root property. The SRP, yeah. Get rid of the square, put a square root. Type that into your handy dandy calculator. You probably get 10.95. So we're going to round that to 11.0. The 5 adds 1 to the 9. 9 becomes a 10, so we got to carry that over. So 11.0. All right, that's it for this video. I'll see you here for the next one. Bye.